Once the micelles which is formed on the surface of the cloth, it will remove the oil and the grease content from your cloth and it will clean your cloth. Any two reactants are combining to give rise to the product. Hence, this is a chemical way of preparing the colloidal solution. Similarly, for obtaining the silver iodide solute, I have added the silver nitrate as a electrolyte, which is a peptizing agent. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Surface Chemistry. Under that, we have talked about the important features of solid catalyst, and also we have learnt about the characteristics of the enzyme catalysis, and also we have learnt about the mechanism of enzyme catalyst and the colloids and the types of colloids also we have discussed. Today, let us move on to the next topic of this unit about the cleansing action of soap. So, how does clean the dirt or the oil which is there in the cloth? That will be learnt by learning the cleansing action of soap, and also the method of preparations of colloid and purifications of colloidal solution we are going to discuss in this session. Now let us see how the cleansing action of the soap will be gone. So we already know that soaps are nothing but a sodium or the potassium salts of fatty acids. Is it right? Let's see how does the soap will mainly act like a cleansing agent while removing the dirt. Okay. So this is a picture, the A, which shows that the grease on the cloth. So this is a picture where the cloth will having a grease. And the second picture which shows that stearate ion which are arranging on the grease droplet. So which will be arranging around the grease droplet. On the grease, the stearate ion, that is RCOO minus, that is a stearate ion, will be get attached on the surface of the oil droplet. In the third diagram, you can see that the grease droplet, surrounded by the stearate ion and results in a formation of micelle. You can see that the micelles will be formed on the entire surface of the grease. Now let us understand what is the mechanism behind this. When soaps are applied on the grease or a oily skin surface, along with the water, hydrophobic R part penetrate into the oil or a grease, whereas COO minus remains in the water. Since our polar groups can interact with the water and the oil droplets are surrounded by stearate ion, this is now pulled by the water and removed from the dirt surface. Thus, the soaps helps in emulsification and washing away of the oils and fats. The negatively charged sheet around the globules which prevents from the coming together and forming a aggregate. This is how soap will be act like a cleansing agent to remove the dirt or oil on the surface of the cloth. So what does the first process? In the first step, when you dip the cloth in the soap water, what the water will be formed? We know that in the water we have dissolved the soap. So what the soap will do? In the first step, it will release a stearate ion. This stearate ion goes and binds on the surface of the oil and dirt on your cloth. In the third step, that stearate ion which forms a micelle. Already I have explained that how the micelle will be formed in our last class. Is it right? Once the micelles which is formed on the surface of the cloth, it will remove the oil and the grease content from your cloth and it will clean your cloth. This is how the soap as well as the detergent which act like a cleansing agent to remove the dirt or to remove the grease on your cloth. Hope you all understood with this. Next, let us see the method of preparations of colloid. So there are three important methods will be there. The first one is chemical method, and second one is peptization, and the third one is Brigade's arc method. Brigade's arc method, peptization and the chemical method. These are the three important methods of preparations of colloid. First we will see how to prepare the colloid by using chemical method. So colloidal solution can be prepared by chemical reactions leading to the formations of molecules by double decomposition, oxidation, reduction and hydrolysis. The molecules are aggregate leading into the formation of salt. Here I have listed out the 4 different examples. These are the different kinds of the reactions where it leads into the formation of colloids. Let's see with the first one. I am talking about the arsenic oxide. When arsenic oxide reacts with H2S gas, and this is a double decomposition reaction, what does it form? It will form a arsenic sulfide, which is the salt, along with the release of water molecule. Similarly, if you take the oxidation of sulfur dioxide with the H2S gas, it will form a sulfur by releasing the water molecule. So sulfur is a salt and this is a colloid. By doing the oxidation with the sulfur dioxide with the H2S gas, you will obtain the colloidal solution. Similarly, you can take the AuCl3 plus formaldehyde in presence of water. This is a type of reduction where you are going to prepare a colloidal solution called as gold that can be obtained by the salts of gold, that is AuCl3. Remember, you can prepare the colloidal solution of the gold by taking the gold salts. Okay, the gold salts along with formaldehyde in presence of water, which give rise to the gold salt and with the release of HCOOH and HCl. This is a type of reduction. And if you comes to the hydrolysis, I am taking the ferric chloride which is stated with the water, which forms what? Ferric oxide with the release of HCl, and this is a type of hydrolysis. So these are the 4 different types of the reaction where any 2 reactants are combining to give rise to the product. Hence, this is a chemical way of preparing the colloidal solution. So which are those? By decomposition, by double decomposition, by reduction, by hydrolysis and also by oxidation, you can prepare the colloidal solution. Next, we'll see with the electrical disintegration, or we can say that it is a brigade arc method. This is also known as what? Electrical disintegration. Let's see how they will do the preparations of colloidal solution by electrical arc method. In this method, electrical arc is struck between the electrodes of the metal which has been immersed in dispersion medium, and an intense heat will be produced that will vaporize the metal, which then condense to form a particles of colloidal state. So here you can see that there is a large container and they have taken out the another container which consists of dispersion medium. Which consists of what? Dispersion medium. And they have introduced the 2 different metal, and this entire dispersion medium will be kept in a ice bath. Now if you apply the electrical field for these 2 electrode which has been dipped in a dispersion medium, these 2 electrode, when you switch on the electrical field, it will receive too much of heat and it will be start vaporizing. When the electrical heat, when it is stuck between the 2 electrode, the metal will be get vaporized, and later that vaporization will be collected and condensed back to get the colloidal salt. This is how, by using the electrodes, they are preparing the colloidal solution. Hence, this is known as electrical arc method or the brigade arc method, or you can say that it is the electrical disintegration. So, what does they do? First, they will take the 2 different container, one which is filled with the ice bath and another will be filled with the dispersion medium. To this dispersion medium, they will use a two different electrode. One is a positive electrode and then is a negative electrode. When you apply the electrical field, what will happen? These two electrodes will be resisted too much of heat and will be get vaporized. Later that vapor will be collected and condensed back to get the colloidal solution. So hope you all understood with this method. Next is peptization. Let's see what is peptization and what is a peptizing agent, how they will treat the peptization. Let's see now. Peptization can be defined as the process of converting the precipitate into the colloidal salt by shaking with the dispersion medium in presence of small quantity of electrolyte. That is known as peptization. What they will do? Imagine in your test tube, you have taken the precipitate of any one of the solution. To this, you are going to add the dispersion medium and you are going to add the electrolyte, small quantity of the electrolyte. So that what will happen? This precipitate will be converted into colloidal solution. This process of converting the precipitate into colloidal solution by using a small quantity of electrolyte is known as peptization. Then the electrolyte will be used for this purpose. They are known as peptizing agent. During the peptization, the precipitate will absorb one of the ions from the electrolyte on its surface, and this causes the development of the positive or the negative charge on the precipitate, which ultimately breaks up into smaller particles of their colloid. So what does the reactions will be inverse? What will happen? We know that our precipitate will receive the positive or the negative ions from this electrolyte. Once it receives, it will begin deposits on the precipitate. Later, it will be break down into give a colloidal solution. Let's take an example where you are going to take the precipitate of FeOH, that is ferric oxide I have taken. To this, I am adding a electrolyte known as ferric chloride. To the ferric oxide precipitate, I have added the ferric chloride as an electrolyte. What does it do? So it receives the positive charge to form a ferric hydroxide salt. Similarly, you can take the precipitate of silver iodide. To this, you have added the silver nitrate as an electrolyte. So you will get the silver iodide. This is how the peptization will be done to prepare the colloidal solution. So what they will do in the peptization, they will take the precipitate of the solution. To that, they will add the dispersion medium and also they will add a small quantity of electrolyte. The electrolyte you are added to enhances the peptization, hence it is known as peptizing agent. Example is, for obtaining the iron oxide or the ferric oxide, or ferric hydroxide salt, you added a ferric chloride as a peptizing agent, which is a electrolyte. Similarly, for obtaining the silver iodide salt, I have added the silver nitrate as a electrolyte, which is a peptizing agent. Hope you all understood with this. Next, we'll see with the purifications of colloidal solution. Now we have understood that how they will prepare the colloidal solution by three methods. First one is by chemical method, by electrical arc method, and third one is by peptization. Now we are going to understand the purifications of colloidal solution. How they will pure the colloidal solution? Why we need to pure the colloidal solution? The puring of colloidal solution in the sense, whatever the colloidal solution you have got during this process, it may contain some of the soluble substances. Sometimes it may consist of excess amount of electrolyte. In order to remove this, we need to go for the purification. Why we need to remove the electrolyte? Because the small quantity of electrolyte can enough to prepare the colloidal solution. But if it is added in excess quantity, it is not good for forming a colloidal solution. That is why, we need to remove the excess quantity of the electrolyte which has been added during the preparation. That is why we need to go for the purification. Let's see which are all the methods will be there. How do we pure the colloidal solution? Let us understand. The process which is used for reducing the amount of impurities and requisite the minimum is known as purifications of colloidal solution. Purifications in the colloidal solution, in the sense it is nothing but a reducing the impurities to the minimum level. That is said to be purifications of the colloidal solution. The first one is dialysis. This is a process where you are going to purify the colloidal solution. Let's see with the process now. It is a process of removing the dissolved substances from the colloidal solution by means of diffusion through the suitable membrane. So, by using the diffusion process, they will remove the soluble substances which is present in your colloidal solution. That is said to be dialysis. For this, they will use a suitable membrane. Okay. The apparatus which is used for this process are known as dialyzer, and a bag of suitable membrane which consists of cellophane sheets, or with the, you can take parchment paper, or with the animal bladder also can be used. You know, they can take it as a suitable membrane containing a colloidal solution which has been suspended in a vessel through the fresh water. Continuously it is flowing. The molecules and ions will be get diffused into the membrane, into the outer water, and pure colloidal solution will be left behind. I can explain with this dialyzer. This entire apparatus which is known as a dialyzer, because which will be used for the purification of the colloidal solution, they were using a process called as diffusion here, hence it is named as dialyzer. You can see that it consists of a larger container, and there is an inlet for putting a fresh water, and there is an outlet for the remaining water to come out. Okay, and they have placed a bag which is made up of dialyzing membrane, which is a thin membrane which will be used in a chemistry for separating the any two mixtures. Okay, so here I have used a dialyzing membrane. It may be a parchment paper or cellophane sheets. So we know that in our bag we have taken the colloidal solution which consists of some of the soluble substances. Is it right? How to remove the soluble substances from our colloidal solution? By placing this bag in the water. So here we are pulling the water, which is a fresh water which is flowing through this bag. So what will happen? Some of the soluble substances, what it is there in your colloidal solution, will be get diffused into the water, and it will be come back through the another outlet. So here crystallites are nothing but a soluble substances, or it may be in the form of electrolyte. It will be comes out and it will be removed away, or the entire bag what we have used that consists of only the colloidal solution. This is how they will purify the colloidal solution by using a dialyzing membrane, and also by a process called as diffusion, you know, they will prepare it. So hope you are understood with this membrane. And next one is electro dialysis. So the process is same, but they will apply the electrical field. Why they will apply the electrical field? Because only reason is the process of dialysis will be quite slow. In order to make it faster, they have used the electrical field here. So what they will do again, they will take the large container, and there is an inlet for pushing the water, and there is an outlet for the remaining water to go out. And they have introduced the two electrode. One is a positive electrode, another is a negative electrode, and they will supply the electrical field. When you apply the electrical field to this entire container, which consists of a dialyzing membrane with a colloidal solution, what will happen? We know that our colloidal solution, which also consists of some of the soluble substances or the electrolyte, which will be get diffused into the water, and it will be removed through the another outlet. Okay, this is how by using the electrical field they enhances the speed of dialysis. Hence this is named as electrodialysis. This is the second method for the preparations of colloidal solution. Next one is ultrafiltration. Ultrafiltrations, the salts are passed through the ordinary filter paper, and the pores are too larger to retain the colloidal particles. So we already know that the ultrafiltration, in this sense, the pore size of the filter paper must be very small, so that you will get a pure colloidal solution while doing the filtration. But how to increase that? That can be done by ultrafiltration. Here, the salts will be passed through the ordinary filter paper. We know that ordinary filter paper will having the two large holes to retain the colloidal solution. That is why they'll add the collidine, which is a 4% solution of nitrocellulose in alcohols and ether. So collidine will be added. What is the collidine here? Collidine is a solution of nitrocellulose in the mixture of alcohols and ether. So an ultrafilter may be prepared by soaking the filter paper in a colloidal solution and hardening by using formaldehyde, and finally it will be dried it. Why they are doing this process? In order to reduce the pore size in the filter paper, because in our normal filter paper we'll having the larger pores, so it cannot retain the colloidal solution. It will be more along with our electrolyte. That is why, in order to reduce the size of the filter paper, what they will do, they will take the filter paper and they have dipped in collidine, which is a 4% solution of nitrocellulose in the mixture of alcohols and ether. Later, they will add a formaldehyde and they will dry it, and they will use that filter paper for the filtration. And the pore size will be later, it will be reduced. In such modification, filter papers are become ultra filter. So why it will become ultra filter now? Because we have added the formaldehyde to reduce the, we have added the formaldehyde to increase the hardness, and also we have added the collidine to reduce the pore size, so that it will be act like a ultra filter now, because the pore size will be get reduced. Later, by using this ultra filter, the collidine particles will be separated out from the rest of the material. If you do the filtrations, that can be retain the colloidal solution, and it will pass out the remaining the soluble substances in your colloidal solution. This is how, by using a normal filter paper, they'll make it into the ultra filter paper, and they'll do the filtration to obtain the pure colloidal solution. The ultrafiltration is a slow process, and it is also speed up by applying some pressure. So, or by using a suctions, which is applied on the filter paper to increase the filtration. So, the colloidal particles will be left on the ultrafilters. Later, it will be stirred with the freshly dispersion medium and get a pure colloidal solution. Here I have a picture where I have uses the UF membrane. You can see that I am applying some pressure to increase the filtration process, because the filtration is a very slow process, as we have already learned, and we know that if you made the filter papers into ultra filters, their entire filtration will become very slow, because the pores are very small. Even the colloidal particle cannot move through it, and it requires a larger time. That is why we can apply some pressure, or we can use on some of the sections to increase the rate of filtration. This is how they'll obtain the pure colloidal solution from the electrolyte or from the soluble substances in your colloidal solution. In the next class, we are going to understand with the properties of the colloidal solution. So by this, I like to say that in this session, we have learned only the preparation along with the purification. In the next class, we are going to learn about the properties, have a look on it and try to work out and try to mention the methods and preparation. We'll meet you in the next session. Till then, take care and be safe. Thank you.